Alright, continuing on with Chapter 5. Let's go through the chapter objectives. Describe data and process modeling concepts and tools, including data flow diagrams or DFDs, a data dictionary, and process flow descriptions. Describe the symbols used in data flow diagrams and explain the rules for their use. Draw data flow diagrams in a sequence from general to specific. Explain how to level and balance a set of data flow diagrams. Describe how a data dictionary is used and what's contained in it. Use process description tools including structured English, decision tables, and decision trees. Describe the relationship between logical and physical models. Going on, we're going to go through the overview of data and process modeling and tools. Systems analysts use many graphical techniques to describe the information systems. A data flow diagram uses various symbols to show how the system transforms input into useful information. We're going to see some examples of this very shortly. Since it is graphic, it'll be easier to show you when the slide comes up. A data flow diagram shows how data moves through an information system but does not show program logic or processing steps. A DFD is more of an overview. It gives you a good glance as to how data flows from one process to another, and that's what it's designed to do. It's not going to show you the logic of how it's done. It's not a technical step. A set of DFDs provide a logical model that shows what the system does, not how it does it. So again, it's an overview. And here is an example of data flow diagrams. There are 4 basic symbols that are used, and they're listed vertically here, and they're listed vertically here. There is the Gain and Sarsen symbols that are used, and then there's also the Jordan symbols. I was taught using the Jordan symbols. When I learned this originally, I was never taught this at all. However, the book uses the Gain and Sarsen symbols throughout. I do believe it looks a little bit cleaner, but they basically function the same way. So keep in mind that this you may see symbols that look similar to this outside of this class, but in this class we'll stick with these. Process symbols must have at least one input and at least one output. So that's an arrow in and arrow out. They contain business logic that transforms the data. Process name identifies the function. It's usually a verb. Process numbers does not signify precedence. We've explained that sometimes. It's just a numbering system and a sequential number in a lot of cases. There are examples such as print bill or add customer. You'll see the word print and add are the verbs here. Data flow diagram represents one or more data items. The symbols for data flow is a line with a single or double arrowhead. So as you can see here, this is a Gain and Sarsen's version of the DFDs. You may also see it with differing symbols like I mentioned previously, but in the book it'll look similar to this, and these would represent inputs, these would represent outputs, and these represent processes. And the processes, like you said, they all are verb driven. Data flow symbols. Spontaneous generation, must process and act on input. There are black holes and gray holes. So if you look at something like this, you see the problem here. There's no input, there's just 2 outputs here. In this one, there's just an output. And let's see what's wrong with calculate grade. Calculate gross pay is no outputs. It's called a black hole. So that's a black hole right there. And calculate grade has an input that is obviously unable to produce output. This is called a gray hole. So the input date of birth, you can't have date of birth in a grade calculation for the final grade. If that was considered in calculation, do you know how much the students would complain in this class or any class? Data store symbols represent data that the system stores. A data flow diagram does not show the detailed contents of a data store. The specific structure and the data elements are defined in the dictionary. A data store must be collected to a process with a data flow. So again, the data store is a DFD that does not show the detailed contents of the store. It just gives you, it's just a symbol. So let's take a look. So continuing on, let's look at some correct examples of data flow diagrams with external entities. These are the external entities. A customer is external, a bank is the external, the customer again can be external. You do have your inputs and your outputs, and sometimes both. And it can go like this. You can have a process go to an external entity and then back to another process. So these are all good examples. You can have an input to a process from an external entity and vice versa. And like I said, you can have a bidirectional input-output to an external entity from a process. That's okay. Examples that are not okay are pretty much any kind of external entity that doesn't link itself and doesn't connect itself directly to a process. And that's what we need to remember here. Now we'll talk about creating a set of data flow diagrams. Create a graphical model of information system based on your fact-finding results. First, you will review a set of guidelines for drawing DFDs. Then you will learn how to apply these guidelines and create a set of data flow diagrams using a three-step process, which we're going to go through. So when you're creating a set, process to process is okay. Process to an external entity is okay. Process to a data store is okay. We've gone through the external entities previously that are not okay, and also data stores cannot go directly to data stores. Here are some guidelines that I'm going to list for creating a set of data flow diagrams. Draw the context diagram so it fits on one page. Use the name of the information system as the process name in the context diagram. Use unique names within a set of symbols. Don't cross lines. Provide a unique name and reference number for each process. Ensure that the model is accurate, easy to understand, and that it meets the needs of its users. Continuing on. So let's draw the context diagram first. So the context diagram is going to be very high level, and this is for an order system. So I'll stop here, let you take a look at that for a second, and then we'll continue on. Now we'll draw a diagram 0 data flow diagram. It mentions here if data flows in both directions, you can use a double-headed arrow rather than two separate arrows like we saw in the context diagram. So what that would mean is you can have, rather than another arrow going from like fill order to customer with the arrow right here, you could have just the arrow on the same line. And I looked at this example and I don't see anything that shows that here, but that's what they're saying. Diagram 0 is an exploded view of a process 0. Parent diagram. Actually, you know what? That's a very interesting way that bullet pointed. Child diagram, functional primitive. Now we start to draw the lower levels. This is a diagram 1 DFD, which shows the specific details of the fill order process. So it dives in a little bit deeper. This diagram does not show the symbols that connects data flows entering or leaving the fill order context diagram. You must use leveling and balancing techniques. Leveling examples. Use a series of increasingly detailed data flow diagrams to describe an information system, exploding, partitioning, or decomposing. So what they're saying here is use a set of smaller leveling diagrams to lay things out and make it so you can pick a section here, or maybe you want to describe the whole thing. Let's now take a look at the order system diagram 0, and let's show the exploded diagram 3 data flow diagram for process payment. So as you can see right here in the diagram, this is the diagram 0. It shows apply payment as a very simple process. In diagram 3, it's exploded out and you can see more of the details. You can see the parent processes, yet you can see that the inputs and the outputs remain the same. Now let's go into the data dictionary. The data dictionary, or data repository, is the central storehouse of information about the system's data. I like to look at the data dictionary as flashcards or cue cards containing the data throughout the system. An analyst uses the data dictionary to collect, document, and organize specific facts about the system. It also defines and describes all the data elements and their meaningful combinations of data elements. A data element is also called a data item or field. This may sound familiar to you database people out there. It's the smallest piece of data that has meaning. Data elements are combined into records, also called data structures. A record is a meaningful combination of related data elements that is included in a data flow or a retained data store. Using case tools for documentation. So nobody wants to flip around flashcards and have paper cards like I was just talking about up top. I said meant that figuratively. People use case tools for this documentation. The more complex the system, the more difficult it is to maintain these tools in this documentation. Modern case tools really do simplify the task. A case repository ensures data consistency. So the case tools in part B of the systems toolkit, I'm not going to focus on that part too much. Documenting the data elements. You must document every data element in the data dictionary. The objective is the same, to provide clear, comprehensive information about the data processes that make up the system. And that was a lot of wording and a lot of talk. Now let's take a look at what that actually looks like. So here is a sample form of online documentation. It's a data dictionary record for a social security number. So we'll call this the social security number. It's the data dictionary. You have the name of the online documentation form, and right here, in identifying what it is, it tells you what system, for example, description and comments, acceptable values, type and length. 9N means 9 numbers numeric. So these are the types of information that we have in a data dictionary, and different data dictionaries will contain different bits of information, but this is a good example of what we really want to see. So now we'll talk about documenting the data elements. The data element name and label. That's social security number. The default type and length. So that was the 9N. I don't know how clear that looks to you, but that's the 9N right there. So that's 9 numeric. So the type is numeric and the length is 9 characters. You have a default value. What would be the default value for somebody's social number? You really don't want to have a default value. It's got to be blank. So it says none right here. Accepted values, domain and validity rules. So it says any digit number, I believe that's what that says. But yeah, it has to be numeric. And source, it's going to say, it's going to say where the source is. The security says it's taken care of and managed by the payroll department. The responsible user is the payroll department. And then there's also a spot to put in comments in this example. This is really difficult to read. I do have the slides where you can possibly expand this and make this more clear for yourselves. Continuing on, we want to document the data flows. So in this example here, in the upper screen, the analyst has entered 4 items of information in the online documentation form. The lower screen shows the same 4 items entered into a visible analyst data form. So you want to make sure this information here remains consistent, and you want to make sure that it's synced as much as possible. Let's go into process description tools. Typical process description tools include structured English, decision tables, and decision trees. Process description tools also can be used in OO development, or object-oriented development. That's development like in C, Java, C++, Java, what have you. So these are object-oriented programming language. Visual Basic, there's lots of object-oriented languages. They have different names and everything. For example, instead of calling it structured English, it's called pseudocoding, but it's the same concept, and they do a lot of this when they're doing object-oriented development. Modular design. It's based on combinations of three logical structures, sometimes called control structures, which serve as building blocks for the process: sequence, selection, and iteration or looping. So these diagrams and these characters right here are what a programmer would refer to as the flowchart. This is a decision when it's a diamond like this, such as this. It's a yes-no decision in this case. Right here, you have the process. We know that because it's a verb. It's represented by a square. And you have your inputs and outputs that you're familiar with. Structured English must conform to the following rules. Only use three building blocks of sequence, selection, and iteration. Use indentation for readability. Use a limited vocabulary, including standard terms from the data dictionary and specific words that describe the processing rules. So, like I said, this can also be referred to as pseudocoding. Decision tables show a logical structure in all the possible combinations of conditions and resulting actions. It is important to consider every possible outcome to ensure that you have not overlooked anything. If there's, rather than it being a yes-no, is there also a maybe? That's something you'd need to look at, those kind of situations. The number of rules doubles each time you add a condition. You can have more than two possible outcomes. Often are the best way to describe a complex set of conditions. So let's look at it here, for example. So this would be an example of a decision table and the possible outcomes. I'll give you a minute. There's a lot here. I'm going to let you just kind of read that for yourself. It is pretty well documented and self-explanatory. So you can see in this example, a third condition has been added. And I will pick this up again by talking about decision trees, which are graphical representations of conditions, actions, and rules found in a decision table. It shows the logical structure in a horizontal form that resembles a tree with the roots at the left and the branches to the right. And this may look like a bracket or something, and it to some degree is. Decision trees and decision tables provide the same results, but in different forms. So you kind of have your choice as to how you lay it out. I personally like the decision trees better. Logical versus physical models. While structured analysis tools are used to develop a logical model for a new information system, such tools can also be used to develop physical models of an information system. A physical model shows the system's requirements are implemented. So let's talk about logical versus physical, the sequence of the models, or sequence of models. Many systems analysts create physical models of the current system and then develop a logical model of the current system before tackling the logical model of the new system. But performing this extra step allows them to understand the current system better because you're going through it several times and you're creating a replication of the situation. I can tell you, you do that at conversion time especially, you're going to have more confidence going in. It's a good idea. There's the four model approach. Develop a physical model of the current system, a logical model of the current system, a logical model of the new system, and then a physical model of the new system. So what's the disadvantage? This is going to take you a lot of time, and it's going to add a lot of cost in both hardware, software licensing. It's going to cost you a lot more in human resource for sure. So, and that's something to consider. So, I've never taken the full four model approach, but it can be beneficial. I do think it can be a little much at the same time. So now let's go through our chapter summary. And this time I will go ahead and just read this off. During data and process modeling, a systems analyst develops graphical models to show how the system transforms data into useful information. The end product of the data and processes modeling is a logical model that will be used to support the business operations and will meet the user needs. Data and process modeling involves three main tools: DFDs, data dictionaries, and process descriptions. DFDs graphically show the movement and transformation of data in an information system. DFDs use four symbols, which we've gone through. A set of data flow diagrams is like a pyramid with a context at the top, and you have level 1, 2, and 3. The data dictionary is the central documentation tool used for structured analysis. So let's remember the data flow diagram. You have the external entity, you have the inputs, you have the outputs, and you have the processes. Each functional primitive process is documented using structured English, decision tables, or trees. Structured analysis tools can be used to develop a logical model during one of these systems analysis phase and physical modeling during the systems phase. And that's it for Chapter 5. We'll be moving on to Chapter 6 now.